Yet again, the world initially began seeing dynamite pictures of the universe caught by the strong James Webb Space Telescope, JWST, sent off by NASA. This aggressive and momentous venture has reformed how we might interpret the universe by sending back a progression of shocking new pictures. These most recent visuals have staggered researchers and lovers alike, giving bits of insight that challenge existing hypotheses and open up new domains of investigation, dissimilar to anything we have at any point observed before. These pictures offer us a brief look into the most far-off and cryptic districts of the universe, pushing the limits of human knowledge to unknown domains. Before we begin hitting the like and subscribe buttons for more exclusive news, the JWST, intended to be the replacement for the Hubble Space Telescope, has surpassed expectations with its high-level infrared capabilities. This permits it to peer deeper into the universe than any other instrument before it. While Hubble gave stunning perspectives on the universe in visible light, the James Webb Telescope essentially works in the infrared range. This ability empowers it to slice through enormous dust mists and uncover the secrets of star formation, black holes, and early universe development. The telescope's most recent pictures have revealed regions of the universe that were previously hidden from us, offering new insights about phenomena that have long confounded cosmologists. One of the main pictures returned by the JWST shows an area of space so far off that it traces all the way back to a couple of 100 million years after the Big Bang. This period in cosmic history, known as the Cosmic Dawn, has been largely shrouded in mystery. During this time, the first stars and galaxies began to form, and the universe started to emerge from its primordial state. Interestingly, researchers are seeing evidence of these earliest structures with rare clarity, allowing them to piece together the events that shaped the early universe. In these new pictures, thick clouds of gas and dust are visible, forming stellar nurseries. These regions are among the most tempestuous and turbulent in the universe, where gravity organizes immense amounts of matter to ignite the nuclear reactions that form stars. The JWST has captured intricate details of this process, showing stars in various stages of their formation and offering a window into the life cycle of stars in a manner that has never been possible before. By studying these images, astronomers can learn about the conditions under which stars are born and how these processes have changed over billions of years. In addition to stellar nurseries, the James Webb Telescope has also captured images of distant galaxies, many of which have never been seen before. These galaxies are found so far away that their light has taken billions of years to reach us, meaning we are seeing them as they appeared when the universe was still in its infancy. The telescope's unmatched resolution has revealed complex structures within these galaxies, including massive black holes at their centers and star clusters that are far older than our own Milky Way. These black holes are particularly captivating because they challenge our current understanding of how these objects form and evolve. Some of the black holes observed in these images are much larger and more active than researchers expected them to be at an early stage in the universe's history. Speculations about how black holes grow typically propose that they start as small dense objects that gradually accumulate mass over time by consuming surrounding matter. However, the JWST data suggests that some black holes may have formed fully developed or experienced rapid growth, prompting cosmologists to reconsider their models of black hole development. The images of these early galaxies also raise questions about how galaxies themselves form and evolve. Some of the galaxies seen by the JWST are strikingly well-structured, with defined spiral arms and central bulges, despite being so young in astronomical terms. This level of organization is surprising, as it was previously believed that galaxies in the early universe would be more chaotic and irregular in shape due to the violent processes involved in their formation. The discovery of these well-formed galaxies suggests that galaxy evolution might occur much more rapidly than previously thought, which has significant implications for our understanding of the universe's early years. The JWST has also provided a stunning new perspective on some of the most enigmatic objects in the universe: exoplanets. These are planets that orbit stars outside our solar system, and while many exoplanets have been found in recent decades, we still know very little about their atmospheres and potential for supporting life. The James Webb Telescope's infrared capabilities have allowed researchers to study the chemical compositions of exoplanet atmospheres more closely than ever before. Some of the new pictures and data have revealed astonishing findings, including the presence of water vapor, methane, and other organic molecules on certain exoplanets. These discoveries are especially exciting because they bring us closer to answering one of the most significant questions in science. Are we alone in the universe? The presence of organic molecules in an exoplanet's atmosphere does not necessarily imply that life exists on these planets, but it suggests that the building blocks of life are more common in the universe than previously thought. These findings could ultimately lead to the identification of habitable worlds beyond our solar system, potentially changing the way we think about life in the universe. The JWST's new pictures also provide crucial insights into the final stages of stellar life. The telescope has captured detailed views of supernova remnants, vast, colorful clouds of gas and dust left behind after a star explodes. These remnants are not only beautiful but also scientifically significant, as they are the sites where many of the heavier elements known to humanity are created. When a star goes supernova, it produces enormous amounts of energy, which fuses lighter elements like hydrogen and helium into heavier elements like carbon, oxygen, and iron. These elements are then dispersed across space, becoming part of new stars, planets, and eventually life itself. The James Webb Space Telescope's new pictures, which delve into the earliest chapters of the universe's existence, have opened a window into a cosmic narrative we previously could barely comprehend. What makes these pictures particularly inspiring isn't just their beauty, but their ability to unlock secrets of the universe that were once thought to be far beyond our reach. These never-before-seen scenes of distant worlds, nebulae, and cosmic structures are compelling us to reconsider what we thought we knew about the universe. While the images of distant galaxies and intriguing phenomena have captured the public imagination, one of the most astonishing discoveries made by the JWST involves objects much closer to home, the outer reaches of our own solar system. The telescope's infrared sensors have been able to study the icy worlds at the edges of the solar system, revealing new insights about their composition and surface features. For instance, the telescope captured a detailed image of Pluto's moon Charon, uncovering a complex landscape of icy plains and mountain ranges that had previously been invisible to us. These observations of the outer solar system could help researchers understand the formation of planetary bodies in cold, distant regions of space. The Kuiper Belt, an immense region of space beyond Neptune that contains thousands of icy objects, has long been a mystery to cosmologists. The JWST's ability to focus on these objects in detail could provide new insights into how planets form in the outer reaches of solar systems, offering clues about how our own solar system came to be. Beyond individual discoveries, the James Webb Space Telescope is also helping to answer one of the biggest questions in cosmology: how did the universe evolve into its current state? By capturing images of galaxies, stars, and planets at various evolutionary stages, the telescope is helping to create a timeline of cosmic history. These observations allow researchers to trace the development of galaxies and stars over billions of years, providing a more comprehensive picture of the universe's past, present, and future. One of the key revelations from the JWST's latest images is the recognition that the universe's early years were far more dynamic than previously suspected. The pictures show galaxies forming at a faster rate than expected, with intense bursts of star formation occurring in rapid succession. This challenges the long-held view that the early universe was relatively quiet and that galaxy formation happened slowly over billions of years. Rather, the first few 100 million years after the Big Bang were a period of intense activity, with galaxies rapidly forming and evolving in ways that researchers are just beginning to understand. The James Webb Space Telescope's ability to look so far back in time is largely due to its unprecedented sensitivity. By observing in the infrared range, the telescope can detect the faintest signals of light that have traveled billions of light years across space. This light, emitted by stars and galaxies in the early universe, has been stretched and redshifted over time as the universe expands. The JWST's capacity to capture this ancient light allows researchers to see objects that are so far away that their light has taken nearly the entire age of the universe to reach us. In addition to looking deep into the past, the JWST is also providing a new perspective on the structure of the universe itself. The pictures reveal vast webs of dark matter and galaxies extending across the cosmos like a spider's web. These networks, shaped by the gravitational pull of dark matter, form the backbone of the universe's large-scale structure. By mapping these structures, researchers can gain insights into the fundamental forces that have shaped the universe over billions of years. The James Webb Space Telescope's ability to reveal the intricate web of dark matter and galaxies enhances our understanding of how the universe is structured. These observations illustrate the gravitational influences at play, highlighting how dark matter acts as a scaffold for visible matter, guiding the formation and clustering of galaxies. This mapping of cosmic structures allows astronomers to explore the distribution of dark matter, which remains one of the greatest mysteries in astrophysics. Understanding its properties and distribution could help answer fundamental questions about the universe's evolution and the nature of gravity itself. Furthermore, the JWST's observations can shed light on the cosmic microwave background radiation, the remnant heat from the Big Bang. By studying galaxies at various distances, scientists can trace the history of the universe from its infancy to its current state, revealing how cosmic expansion has influenced galaxy formation over time. The telescope is also poised to contribute significantly to our knowledge of galaxy mergers, a key process in cosmic evolution. By observing galaxies in different stages of merging, the JWST can provide insights into how these interactions influence star formation, galactic morphology, and the growth of supermassive black holes at the centers of galaxies. As researchers analyze the data collected by the JWST, they are increasingly able to piece together a cohesive narrative about the universe's history. Each new discovery builds on previous findings, creating a more comprehensive understanding of the processes that govern cosmic evolution. In summary, the James Webb Space Telescope is not just a remarkable engineering achievement. It represents a significant leap forward in our quest to understand the universe. By unveiling the distant cosmos with unprecedented clarity, the JWST is transforming our perspective on everything from the formation of stars and galaxies to the potential for life on distant exoplanets. As the data continues to pour in, it holds the promise of answering some of humanity's oldest questions about our place in the universe, ultimately reshaping our understanding of existence itself.